Assalamualaikum guys, welcome back to my YouTube channel which is Chromatography. I hope that you all are doing good and well. So we are here with another interesting topic of the chromatography, which is another type of the chromatography, which is the gas chromatography. So let's see what is the gas chromatography. It was invented by the A.J.P. Martin and thus since recommended that the liquid mobile phase used in the liquid chromatography could be replaced by a suitable gas. And the Fritz Spreyer first developed the solid state gas chromatography. A more sophisticated form of the gas chromatography was conducted by the James and the Martin and described by the James in the 1955. What are the types of the gas chromatography? First one is the gas solid chromatography. Its separation is based on the adsorption. The stationary phase in this case is the solid. It is the affinity of solutes towards the absorption into the stationary phase, which determines in part the retention time. The mobile phase is of course a suitable gas carrier. This gas chromatography technique is the most useful for the separation and the analysis of the gas like CH4, CO2, CO, etc. Another one is the gas liquid chromatography. Its separation is based on the partition. Stationary phase is a liquid with a very low volatility, while the mobile phase is a suitable carrier gas. And the gas liquid chromatography is the most widely used technique for the separation of the volatile species. The more important of the two is the gas liquid chromatography used in the form of the capillary column. What is the principle and theory of the gas chromatography? The gas chromatography is the chromatographic technique where the sample is vaporized by the injection into the heated column by an inert gaseous mobile phase. In this technique, the mobile phase is a gas and the stationary phase is a solid or a liquid. If the stationary phase is a solid, then it is known as a gas solid chromatography, and when the stationary phase is liquid, it is known as a gas liquid chromatography. And this method is mainly used for the separation of the volatile substances which are not conveniently handled by the high performance liquid chromatography HPLC. Further, we have the instrumentation of the gas chromatography. Its main component include the gas cylinder, flow meter, pressure regulator, injector, column, detector, amplifier, recorder, and so many other things. This one is the diagram of the gas chromatography. Okay, further we have now we will see the detail of one by one the component of the gas chromatography. First one is the carrier gas, and it is chemically inert gas available in the pure form such as hydrogen, helium, hydrogen, argon, air. Hydrogen, it has a distinctly better thermal conductivity in the lower density, and helium, it has excellent thermal conductivity, low density inertness, and its permit greater flow rates. It is highly expensive. It is most commonly used. Further, we have the nitrogen. It offers reduced sensitivity and inexpensive. Air is the only employed when the atmospheric oxygen is beneficial to the detector separation. Further, we have the temperature programmer. The column is placed in the thermostatic oven. There are commonly two temperature programmers used. First one is the isothermal programming. In it, the temperature is kept constant during the entire analysis, and second one is the gradient programming. The temperature is differentiated that it is increased or decreased during the analysis. Diagram of the isothermal programming and the programmed temperature programming peaks are here. What are the pressure regulators? The pressure regulator is mainly used to regulate the pressure in the range of 10 to 50 psi for the flow of the carrier gas with a flow rate of 25 to 150 milliliter per minute with packed column, or 1 to 25 milliliter per minute for the open tubular column. Sample injector system. Sample injector system is mainly used to introduce the sample into the carrier gas flow to the column, and in the gas chromatography, the sample injector system used is mainly based on the state of the sample. They are follows for the gaseous sample. Gaseous sample, the rotatory valve is used, which is same as the HPLC, except the sample loop is larger in the GC. GC is the gas chromatography. Let's see for the simple sample liquid. A gas syringe is used. Sample is introduced or injected with a 1.5 to 10 micrometer graduated syringe through the septum into the heated flash evaporation injector. Then the sample is vaporized and the carrier gas pushes the vaporized sample from the injector to the column. This one is the sample injector. For the solid samples, the sample is initially volatilized. To convert the sample into the volatile derivative, in some cases pyrolysis is used to vaporize the solid sample. The pyrolysis is nothing but the sample is heated to the 270 degrees centigrade. After placing it in the injection pot and the vaporized sample is again heated. At the end we see what are the columns. The most important factor in the gas chromatography is the selection of the proper column, which is the stationary phase for the particular separation to be attempted. Gas chromatography always uses flow through the detectors that automatically detect the analytes as they elute from the column. There are the two types of the column, packed column and the open tubular column. At the end we will see what are the detectors. The detectors used in the gas chromatography are the thermal conductivity detector, flame ionization detector, electron capture detector, thermo-ionic ionization detector, flame photometric detector. I hope that you understand it, what are the basic types of column and the detector also. And if you completely understand the gas chromatography, go and like my video, subscribe my channel and wait for the other important topics of the chromatography. Till Allah Hafiz.